So here's how your underlying FSS mount looks like. So if I do an ls here, you can see all the S3 files. And if I go to one of them and just do an ls, you can see the partitions that we created for our table. And if I go to this one, you will also be able to see the hourly partition for the hour 13. And this is getting asynchronously updated. And this is from our S3 as well. So if I go to this table, this is where my metadata will be stored. So if I go to the data as well, you can see the different folders, and if you can see the same order time. So basically, the S3 is asynchronously copying the data over to the FSS cluster so that the reads can be served from FSX to make it faster. And whenever you do a streaming use case as well, this is very helpful. And the ingestion will be at a much faster rate. So FSS cluster will be able to serve your reads at a much faster rate. Okay, moving on to the final use case I wanted to show you is using object storage location provider for S3 traffic shaping. I'll keep it fairly brief. So here I've created, this is the Redshift TPCH data set. You can use it as well. It is public. And the same thing, you can see this information in the notebook I've shared, in the GitHub repository I shared with you under the notebook folder. So I've just created a data frame on top of this TPCH data. And you can see the data set here, data frame here. And now I'm going to insert this data frame into our Iceberg table. So I've created an Iceberg table on top of the same catalog. And I'm going to insert. Oh, and before I insert, so here is how I've created the Iceberg table. These are the two options that are most important. One is you would set the right object storage path enabled, set to true, and you would provide a storage path here. And it is highly recommended. You can provide an S3 bucket name and prefix name and so on, but it is highly recommended to keep it at the root level, which means create a separate folder or a separate S3 bucket for this purpose and use that S3 bucket as much as possible so that the hashes are created at the root level, and it makes it easier for S3 to scale. So now I'm going to insert the supplier data frame that we created earlier from the Redshift TPCH dataset, and I'm going to write to the table that we just created above. Once we are done, we can see the S3 location. You can see I've done a head here which is going to just show the first 10 values. But if I do it outside, you can see the different hash prefixes that got created. And I can also show you the word count. About 1600 prefixes got created, and it will also create more as and when you add more data. And these are all the hash prefixes. Basically, Iceberg uses more hashing algorithm to create the hash prefixes on this particular location that you used when you created the table. And if I go to one of them, for instance, if I do a recursive listing on one of the hashes, you can see the Parquet files that has been created under the partition, that the partition database name, table name, and the partition. Nation key is our partition key in this table. And under that, you can see the Parquet file. And if you have nested partition, then of course you will have the nested structure and then the Parquet file. Similarly, if you query another hash as well, you will see one Parquet file here. And the reason why this is beneficial is when we work with the enterprise customers, that they are working with huge volumes of data, like terabytes and petabytes of data, right? And S3 503 throttling errors and also performance bottlenecks on S3 is very, very common. It's something that we encounter on a daily basis. And this is the reason why Iceberg introduced this feature, because the way the traditional S3 objects are laid out, for example, let's even query the previous ones, like this one, for example. Right. So here, the prefix is the same. So here you have 2023. Maybe I have one folder for 2022. I have too many folders for 2023, too many folders for 2022, too many folders starting with 2021, right? That's how typical production system looks, because when you do a date-based partition, that's how it usually looks. And S3 applies certain limits. Here in this case, it applies 5,500, I guess, gets per second, and 3,500 puts per second are allowed. And it's based on your prefix structure. It's not like it's not like 1:1 mapping, like prefix to the values. It's basically based on your prefix structure. So if you have too many prefixes with the same pattern, then that is a cause of an issue. Your S3 will not be able to scale properly. In that case, what our customers would usually do is like they work closely with the S3 team and maybe like pre-partition their prefixes, which like many of our very large enterprise customers do that. But a better way of handling that is if you're able to provide a hash right in front of your table partition, right? So this is much easier because there is a lot of like even the first character, like 7A, and you can see some 7B, 7C. So it is a lot more diversified, the prefix structure. Like the pattern is like it doesn't look the same. So it's much easy for S3 to scale in this case. And this has been like really invaluable for many of our enterprise customers. And that's the last thing I wanted to show you. And I can select from the table as I would from any other normal table. And I can also like query the system tables like history. And we did only one insert here, so you can just see one snapshot. So that pretty much brings us to the end of this demonstration. And like I said, you can leverage the EMR and FSS Luster use case, especially for streaming workloads and for any other workloads like GDPR, CCPA, so whatever workloads you want to use.